Hi everyone, this is a 5-minute video on IPv4 addressing, produced by Zach. In this video we'll talk about IPv4, its characteristics and role, the addressing, subnetting within an example, and conclusion. What is IPv4? It is the default widely used protocol in the world, a key function at the network layer for the OSI model or internet layer for the TCP/IP model. Its characteristics during data communication are a low overhead, which means it is unreliable as it works on best effort delivery. However, this gives it less delay in delivery. It's connectionless and therefore provides no handshake before sending data, and it's media independent during data delivery. During data transmission, it encapsulates segments from the transport layer into packets by adding a header, which is a key feature considered by devices like routers during data delivery. The headers contains source and destination IP addresses, TTL, time to live, which holds information on the remaining life of the packet. When it's at 0, it is discarded. Type of service, which determines the quality of service provided. Its role is to uniquely identify each and every device on the network and the organization of networks. The division of these networks is based on their purpose, ownership, and geographical location. IPv4 addressing. It is made up of 32 bits covering two parts, the network portion and the host portion. The 32 bits are divided into 4 octets of 8 bits each in binary, which is represented by a dotted decimal to give the IP address, such as this example. We convert binary to decimal to give us 192.168.32.16. There are 3 address types. Host address, unique for every device on the network. Network address, where all the host bits are zeros and it's common for all devices on the same network. Broadcast address, where all the host bits are ones and is used to send data to everyone on the network. Other ways to send data are unicast, which sends data to one individual host, and multicast, which sends a selected group of hosts. IPv4 provides private addresses that are not used on the internet, ranging from 10.0.0.0/8, 172.16.0.0/12, and the 192.168.0.0/16. IPv4 is divided into classes as seen in this table. Class A ranges from 1 to 127, however 127 is only used for loopback addressing. Class B is 128 to 191, and C is 192 to 223. D and E are used for research and experiment only. Notice how the subnet mask is used to identify network portions and host portions, whereby all ones identify the network portion and the zeros identify the host portion. Subnetting. It's used to relieve network congestion and create multiple small networks through bit borrowing. To calculate the subnets, we use 2 to the power n, where n is the number of bits borrowed from the host portion. To calculate number of hosts, we use 2 to the power n minus 2. N is the number of bits left, and minus 2 is for network and broadcast addresses. An example is we have one network with one portion of hosts, 1 to 254. By the way, a '24 means the number of bits in the subnet mask, 8 plus 8 plus 8. If an organization needed 3 networks with 55 hosts each using subnetting, we can create multiple networks. 2 to the power 2 gives us 4 subnets to accommodate the 3 networks, borrowing 2 bits from the host portion, leaving 6 bits, which gives us 2 to the power 6 minus 2, 62 hosts on each network. Borrowing 2 bits from the hosts gives us .192 or a /26. We can use the 2 bits borrowed to generate 4 networks as shown here. The .0 network, the .64 network, the .128 network, the .192 network. And from that we can produce the first and last host for each network and the broadcast address for each as shown here. That brings me to the end of this video. I hope you've learned something about IPv4 and addressing and subnetting.